Hello everyone, welcome back to my channel, Tech Tutor. Today we're going to talk a little bit more about the Spring Boot application that we started in the last video. If you haven't seen it, check it out. I'll put the link in the description. So today we'll go a little bit more over the POM file, the dependencies that we included. I'm going to show you how to set up a sample controller so that way we can have a endpoint that we can return our configuration values. So we'll also wire up some configurations. And then I'll also show you how to use Postman at a high level, and we can dig into that later. In our last video, we used Spring Intializr to create a quick base project, and so we're looking at the POM file that was generated using Spring Intializr. So let's take a look at some of these dependencies and other items that are in this POM file and explain exactly what each one is. So up here, the parent is a Spring Boot parent project. We're using Spring Boot Starter Parent 2.4.0. What this will do is it will automatically manage the dependencies of our other dependencies in the project. What I mean by that is there are versions that Spring Boot keeps track of. So if you hold control and you hover over something like Spring Boot Starter Actuator here, you could see the version it's actually pulling from that parent project is 2.4.0. for the Spring Boot Starter Actuator. If I control click in, you'll see more about that actuator dependency. I'll close this file. We also have the group ID, which is com.example, which was just part of our generated project. So basically, a lot of times you'll see 2 words here for the group ID. It could be anything. It's really just for helping to structure your files. You'll see here over here on the left that it starts with the group ID followed by the name of the project. So this is pretty flexible. It's not really going to impact your code. You're really able to name these whatever you want, but the naming convention is usually to have 2 words for the group ID. And then we have a version for our current project, which is starting as snapshot. If you were to make tags or however else you decide to version, you'd probably change this value, but we won't worry about that too much for now. Now, looking at this next part, you can specify different properties. So I could actually put the versions for the dependencies down here below and then put this in the properties up here. It's not important to go over that right now, but just know that this property is managing our Java version, which happens to be 11. That's what we picked in Spring Intializr, and so that's why it's here. And now let's go to the dependencies. So if you're wondering, what is Spring Boot Actuator for? Well, Spring Boot Actuator is used to create simple health API, as I showed in the last video. If you haven't seen that video, I'll put a link in the description. It also provides different database information, metrics, traffic information. Basically, you can put up something that monitors all the APIs that the Spring Boot Starter Actuator generates, and it kind of helps you keep an idea of the health status of your server and other, again, metrics for traffic, etc. The next dependency is the Spring Boot Starter Web. This dependency actually consists of several other dependencies to help you get a web application up and running quickly. You can drill down into this if I, again, click Control, click on the artifact ID here, and you can start looking at what this POM has for everything the Spring Boot Starter Web project has. So it's got all kinds of extra things that we're not concerned with in our particular project, but the people who maintain Spring, they put this together. So you can see how it has Spring Boot Starter, Spring Boot Starter JSON, Tomcat, Spring Web MVC. So at a high level, basically it's just to help you set up a quick web server in Spring. All of these different dependencies do different things. So the Spring Boot Starter dependency is used to pull in most of Spring's core code for auto configuration, configuration files, logging, syntax, and other essential code for the Spring framework. The Spring Boot Starter JSON dependency here pulls in Jackson, which Jackson is used to serialize Java objects into JSON or deserialize incoming JSON request. If you're not familiar with what JSON is, just let me know in the comments. I'll give you a quick run through what that is. Otherwise, we can talk about it in a future video if you really want me to drill down into it further. It's not anything too complex, but it's used to help turn the JSON payload that's coming in into a serialized object, or take an object and put it back out to a JSON string. Your Spring Boot starter Tomcat, this dependency is used to spin up an HTTP web server to run your Java code on. And the Spring Web module brings in basic web-oriented integration features such as the multi-part file upload functionality and the initialization of the inversion of control container using servlet listeners in a web-oriented application context. It also contains an HTTP client and the web-related parts of Spring's remoting support. That part I'm pulling, for the most part, from Spring's documentation if you want to look at it. But in general, if you're not familiar with what inversion of control is, it's what everything is built on for Spring. Spring has this concept of what's called Spring Beans, and we can get into that a little bit later. Just know that for this video, again, we're just showing you how this Spring Boot Initializer got everything up and running quickly, a little bit of what each dependency is, and if you'd like to hear more about Spring and inversion of control and everything else that Spring's about, just let me know. I'll make a video of that in the future. Now I'm going to go ahead and close this POM file that we opened up, and we will look at our next dependency, which is the Spring Boot Configuration Processor dependency. It's basically a great tool to help you add properties in your application.properties file, or if you have an application.yaml file. When you add this dependency, it'll help you suggest what properties that you can set. So it'll use the predictive or suggestive text rather in your properties file. So if you start typing out properties, it'll tell you which properties you could choose from. Unfortunately, in the community edition of IntelliJ, it doesn't do that. But what it will do is it'll still build a file when you do your clean install. And so this file you could take a look at. Basically, it will be what the project builds in order to help do that suggestive text. In order to generate that metadata, though, you will need to have the annotation at configuration properties in your config file. So let's go ahead and create a example configuration file now. So to create this configuration file, let's go to the com.example.demo. We'll right-click it. Let's go ahead and create a package to hold all of our configuration files. So we'll just call it configuration. And then right-click again, and we'll say a Java class, and we will call it just app configuration. And now, as I was saying, we're going to want to add actually two annotations. One is at configuration. This is so that way Spring will scan this file and add it as one of your beans, as I was saying earlier. Again, we could dive into this more in an actual in-depth video on Spring later. And then the other one you need for it to pick up that property to generate the metadata is at configuration properties. And then there's also a property here that we could set, which is prefix. We're going to do this so that way we can set the prefix in our properties file. So we'll set that prefix as app, and I will show you in just a moment how we add that in our properties file. Additionally, we want to have a property that we can set. So we will say private string config value. This has no getters or setters. So assuming this is a more advanced video, you understand how to create getters and setters. So what we'll do instead of doing that manually is we'll actually utilize Lombok, which is another dependency in here that we pulled in, which I'll go over more in detail in just a second what that's doing. But one of the annotations you can use is called at data, and this will generate getters and setters for all of your field values here. So our config value will now have a set config value and a get config value. It'll need this in order to set the configuration properties. Now let's go back to our POM file. Okay, so as I was saying, let's talk about the Lombok dependency. So the Lombok dependency helps you create a bunch of boilerplate code, such as the getters, setters, could be used for constructors and even logging. So I'll also show you how you can add logging easily into your project with the Lombok annotation for that. And As I just showed you in the configuration class, we did the @data annotation, and that will generate our getters and setters. And this final dependency is the Spring Boot starter test dependency. We're not going to go over that in this video, but what it is used for is it is used to create your unit tests. So there's different annotations and other code that Spring has created for us to help us do our unit test. Now that you have a better understanding of all the dependencies in our project, let's go ahead and add more code using more of these dependencies so we can showcase really what all these dependencies are doing for us, at least at a basic level. Again, we could deep dive into some of these dependencies if you'd like. Just let me know in the comments. Again, I'll probably have other videos being more in depth with Spring, or even if you want a video just on Lombok, that'd be great. Let me know. I can do that for you as well. All right, let's go ahead and set our properties. As I was saying earlier, in our app configuration file, we had created this prefix app. And so you could do either an application properties file. I personally don't like to use this because I feel like it's easier to read the YAML format. So I'm going to do the YAML format though. So I'll go ahead and delete this file. I will right click. It has to be in resources. I will say file and I'll do application.yml. All right, and then there are built-in properties in Spring which you could use. So I'll just show you one of those we'll set so we can actually change the port that the server runs on, which is server port, and then 8080 is the standard port. I can change it. Unfortunately, again, because it's the community edition, you can't drill into any of these dependencies. So if I do the next one, which is the custom dependency the custom configuration that we created, which was under app and then config value, and we'll set that value just to test, you'll see that I can't actually control click in here. Now, if you are using the non-community edition of IntelliJ, when you control click this, it'll actually take you to this file right to this point to show you exactly which property is linked to it. So when you are using not the community edition, I suggest utilizing that feature. It's great, it's helpful. And one other thing you need to do for this to work properly is you also need to go into your demo application file, and underneath or above, I would just add @enable configuration properties. Now we will do a clean install. So I'm going to click this blue lightning bolt item to skip the test because it did generate tests for us, but we're not going to write any of those in this video. So we'll skip those just so that way they don't run and fail because we're not modifying that file at all. Clean will clean the build. So there's nothing there, but if you do it, it's just going to keep doing the same thing. So you double click it, it'll run the clean, which again, if you did build files, your target that builds, it would just delete those files so that way you can freshly build them. Now double click install. As you can see, it's compiling down here. And what you're going to see in just a moment is that it's going to generate that file I was talking about because of this dependency we have, the Spring Boot configuration processor. So under target and then classes, meta INF, this file was generated. And again, this is the file it uses to help predict what properties that you would be wanting to set inside your properties file. So as you can see, it picked up our app configuration class with the prefix app, and then either way is actually valid, this camel case, or you could have even done config-value. So it would pick that value up if you were to set it here. And again, that's why you could later on control click. All this is how Spring is helping to predict which properties you'd like to set. Next, let's finish up our basic project here and add another module. So we will add one for our controller. So new package, and we'll call this controller. And then under that, we'll go ahead and create a Java class again. Call this one demo controller. In here, we're going to need a few annotations. So let's first add one for logging. Now, again, this comes from Lombok. You can see it here as it's suggesting to you it's coming from Lombok. What this will do is it helps set up the SLF4J logging for your project. Lombok is making this much simpler than it normally is. And I'll show you just in a minute how you could put your log statement in. The next Lombok dependency that I'd like to add is @required args constructor. So when you bring in other dependencies, like I'll bring in our app configuration, so private final app configuration, you could do it this way with the required args constructor, or if you had not pulled this in, you'd have to do the standard other way of pulling in these types of dependencies, and you do something like this, where you'd say auto-wired. So Spring knows how to basically come in here and inject that app configuration class after it's been created by Spring, and then you have that value there. But to avoid having to put auto-wired on all of my dependencies, I like to use required args constructor, which again is part of Lombok. So I'm going to just undo my changes there and go back to that. The next annotation you're going to want to add is @controller. So this is just really allowing Spring to know that this is, again, a bean it needs to wire up, and for other developers that are coming in here, they'll know that it is a controller, and there's other, again, aspects of Spring that it knows what this annotation is. If it has any extra pieces of logic it needs to wire in, it will, but we'll keep it at a high level for now. And the next thing is @request mapping. And basically what this will do is after your localhost :8080, this is how you add another part to your URL, which I'll show you in a moment when we go to see what this controller has. So we're just going to call this one /demo. Lastly, we want to actually create an API endpoint that we can call to fetch values from our server. So let's go ahead and add another annotation called Git Mapping. And the path we will set for this one, we'll just do empty quotes. Basically what this is going to do is it's going to say when the user goes to your server /demo, and then there's no deeper path, so just /demo, and they use a GET request, that's when they'll hit what we're about to write here. And we're going to say that it produces media type dot application. Oh, it actually predicted the wrong media type. Let's try that again. I want the Spring Framework HTTP version. Now it'll find it. Application JSON value. So again, this is just telling you that this method we're about to write, it's going to be a GET request that produces back a JSON response. And now let's actually write the method. So public, and we're going to return a response entity. This is part of the Spring Framework. And we'll call it get current configuration, I can type here, value. And so there's our method. We'll now add a log statement. So using the slf4j log.info, say my config value is, we will concatenate that with the actual value. So that dependency that we have said we want to automatically wire into our demo controller is app configuration. So we're going to take that, and then we already have getters and setters because, like I said, we use that @data. It also even has the toString from that data. But we'll go ahead and say the getter, so get config value, and what is it going to call in the end? So this will now log the statement my config value is, and then the value coming from that configuration. If you control click it, you can see it takes us over here. So it is there, it's wired up correctly. Next, we need to fix one last part. It's not returning a response entity, so that's why it's still showing red here. So we'll say return new response entity. This could take just the HTTP status response, but we also want to provide a payload back. So let's go ahead and say the payload first, which is get config value, and then HTTP status dot okay. I will push enter this time so it actually pulls in the dependency. That was my mistake a minute ago. All right, and now we have a very basic controller, and when we run our server, it's going to, again, create a Git API endpoint under demo, and when you call it, it'll log to our console. My config value is the value coming from our application YAML, and then also when you call it, it'll return a payload where the response entity will contain the config value, and it will also return a value of 200 OK. So to showcase this, let's go ahead and use Postman. So I'm just going to bring up Postman and show you how you could wire this up. We'll go into a deeper dive of Postman, how you can get set up if you'd like to. See that, let me know. I will also put a link in the description of where I got Postman from. But for now, just so that way we could wrap this project up, let's go ahead and open up Postman. All right, so I'm gonna go ahead and open up Postman, which I already have installed, but again, I'll put a link in the description. And what we're gonna need to do is add an API call here, so that way we can call that Git API that we created. So we'll click this plus button in Postman. That opened up a new tab for an untitled request, because you could save this into your collections of requests for later. It's great. That way you could always have all these set up and you don't have to keep creating them. But for this video, we're just gonna go ahead and type into here HTTP localhost 8080, and then that's the port it's running under /demo. Now, the one thing I did forget to do is let's go back to our project real quick and let's run it. That way it actually stands up this Git API. As I showed in the previous video, the Actuator API is also up. So we could actually add into our health API if we wanted to as well. But the other thing is it's running on port 8080. And if we come back to Postman, and now we click send, it's going to hit our server. Oh, that's my mistake. Looks like I'm missing another slash. Now let's try that again. It's going to hit our server and we get back the value test, because test is the value that we set for that configuration value. And it also returned the status 200 OK. That is exactly what we expected. So if we come back to our code, you could see that it was expecting 200 OK, and the log statement of my config value is test. So that's everything. That's basically what we set up in this video at a very basic project level of a configuration file to set the config value, which was test. We have a controller with a Git API. And again, we even have a logging statement because of Lombok, making it easier for us. And we also have this response entity that we're returning, which returns, again, our config value and the HTTP status OK. So that wraps up this video. If you like this video, please click the like button and subscribe for future content. I'll be happy to deep dive into any topics that you'd like to hear about. Let me know in the comments, and I'll see you next time.